Here we have a fan display. These are not very common displays, but they are a form of LED displays, and all they have is a fan with a row of LEDs, and these LEDs have different colors, so they can produce a light of different wavelengths at different times to produce a picture. We'll start from the top. Use a screwdriver. Also be careful with this. So this is just a cover with a clear plastic glass that covers the inside of it, and this is how the inside looks like. You can see it's not as simple as it looks from the top. It's quite a mechanism. There's a row of ICs, and each of these ICs controls a few LEDs. And so these ICs are used to switch the LEDs at a particular moment to give a particular color and at a particular point in time. Now, this one had been opened before, and that is quite evident by the missing screws. This one and that one. This display is a custom made one. So the ICs do not have a number on them. They are not labeled. They are not a kind of an IC that you find in your local shop or online electronic shop, because they do not have a number on them. I'm sure there are similar ICs that have a number out there in the market. This one does not have a number on it. If you look closely, even these other ICs are not labeled at all. The two big ICs do not have any writing on them. They are not labeled, but the only label on them is that dot that shows the direction in which you should mount it. Now, as you can see, the sheer number of LEDs on, not LEDs, but ICs on there is kind of prohibitive when for manufacturers to make these ones for mass consumption. If you need this number of ICs to get basic resolution, then you can imagine the number of LEDs you need to get 4K resolution, because that is the standard these days. We have 42 ICs plus the two big ICs. Those are 44 ICs plus that small one, which is the 45th ICs on this top. On the top of this motherboard, and then because this one is not screwed down, you can look at the bottom. There isn't much at the bottom except for the motherboard traces And then we have the SD card mount, where you put in your micro SD. And if you look closely, you can see there is nothing at the back except for this, and this one, which is probably a 3-volt power supply or something like that. When you plug it in, at the bottom here. It has a port for a 12-volt power supply. Okay, we'll go further into it. Now the whole fan assembly is out. Now we have the bottom part, and there isn't much on the bottom part. Okay, that's how it looks like, the bottom part. And you can see there is there's a motor here, probably a 12-volt motor. It's quite loose. It's not supposed to be loose. And as you can see, there are 2 wires that lead to the top of the there are 2 wires that lead to the top of the fan mount for this housing, but there are no wires that come out of this housing into this one. There are no wires for that, because this uses a wireless power transfer, and this is actually necessary. It's not a fancy thing, it's necessary because you cannot have wires crossing from the stationary part to the rotating part without having to make some kind of a very complex joint here. So they necessarily had to have wireless power transfer here. Now this is the inside, and you can see it's nothing but a power supply. This side of the power supply obviously supplies the upper part up to this point. And you can see within this top part here there is a coil in there. There is a coil in this top part, only that you cannot see it. That is supposed to that creates an electromagnetic field whenever you plug the power into it, and that rotating field is what induces current in the upper part, which also has a coil on it. The coil in the upper part, it's within the plastic, and there's a screw on it. I don't know. I don't think it would be wise to try to break the plastic to see the coil inside there. So there is that coil on which power is induced, and then it comes directly to this board here. This is the secondary coil. You can see the coil, it's a flat coil. You can see through that tiny hole here, through where the wires go. You can see the coil inside there, but it's encased in this plastic here. On the other side of the plastic, you can see there is nothing really. So there is no physical connection between the rotating part and the bottom housing here. You can see the bottom housing is just where you mount the fan, and this is just plastic. But when you look at the bottom part of it, you can see that there is a wire that leads to a similar coil at the bottom, and you can see through that small hole. You can see the coil inside there. Now this is the primary of the transformer, and the secondary is in this one. So this is a wireless power transfer mechanism, because this one is on there like that. This is the rotating part, and this is the stationary part. So the stationary is the primary. Now this is a DC motor that uses a magnet inside, and you can feel it when you move. When you move this one, you can feel that it has got a little bit of resistance, meaning that it uses a magnet and a winding with a core. So we reassemble the motor, and we'll make some of these things tight. They're supposed to be tight. I forgot to add tension to the base. It feels okay. That. There we have it bolted down, and you can see already this one is far much firmer. It's not kind of vibrating. So whatever you do, make sure that the memory card is on this notch. The moment the memory card slot here is matches with this slot there, like that. These are some screws I got from an old cassette player, motor assembly, and we use them on this LED display. So there is our LED display. We check first if it hits anything. It says that there is no memory card in it, but you can see it works. Okay. We will now put this one on. We put the cover on and we will do it once more. You check first that it hits nothing. We now use the micro SD card and like that. the image is inverted. As you can see, this is it. We have inverted the setup, and we are going to change the position of the camera. We'll now switch it on. You can see this is some sort of a transparent display. This is just a basic video. You can have something more, a little bit more complex than this. I'll switch it off, and as you have observed that this display has some advantages, but it has also got too many disadvantages against conventional LCD, LED and LCD displays, because you can see it has a danger of the spinning fan. So you've got to find some space for it to operate. Like, you cannot use this on a television set or on a computer, because you will have to find a way. You'll have to find a way to mount it on a computer, in which case it will become too bulky. The other thing is that you've seen the number of chips inside the circuit, and there are just too many of them to make any economical sense in terms of pricing of the product or the power consumption. So it's not a very efficient. It's not an efficient machine. It uses too much power to produce an average quality image. It also needs too much. The device itself is simple, but it uses too much hardware to achieve that effect. The advantage of this one is that it's transparent. It's some kind of transparency. It can be used for billboards, to advertise and things like that. But you can also see that if this is on 24 hours a day, all days of the week, you can see that it will sustain a significant amount of wear, and it's not a very practical kind of display. It's fancy, but not practical for many applications. It's just an idea that has been implemented to demonstrate that this is certainly possible. Now, like the video, subscribe, and please share. That is most important. You can post it somewhere out there.